Problem number 2 says use your graphing calculator to help you out. We have a situation we have for all time greater than or equal to 0, particle moving along the x-axis again. This time our velocity is this rational expression, and the particle once again is at position x equals 3 at time t equals 0. So for starters, when is the particle moving to the right? A particle moving to the right when the velocity is positive. So let's get our graphing calculator to help us out with this. We'll put that right here. Okay, so here's our function in y1, and I set my window up. You can see here, we're interested in x. T is positive, so we'll start -1 so we can see the axis for the y. Stop at 8, we can go further if need be, and let's focus in around the x-axis. So our y-min -2 and y-max 2. If you take a look at the graph, we get a pretty good picture of it. Again, we're interested in the particles moving to the right. Particles moving to the right when our function is positive. So we've got to find those two 0 values. So remember, we do that by second trace, and we have our 0 value. And it wants the left bound and the right bound, so let's go for that first one. It happens between 0 and 1. So my left bound I'm going to type in 0, my right bound I'm going to type in 1, and I'm going to guess 0.5. And we see there it's 0.2679, so that's our 0.2679. And now we need our right bound, so 1, 2, 3. It happens between 3 and 4, so we'll do the same thing as before. So second trace, option 2 is 0. And we said between 3 and 4, so left bound is 3, right bound is 4. Once again, we'll pick 3.5 as our guess, and it comes out to 3.732. There is the interval in which our particle is moving to the right. Okay, part B. Write and evaluate an integral expression that gives the total distance traveled by the particle from t equals 0 to t equals 6. So total distance is equal to the integral from 0 to 6 of the absolute value of our velocity function. All right, now our velocity function is in y1. So we're going to go to the main screen and do math 9, 0 to 6. Absolute value is alpha, and then you hit the window button, and it's option number 1. And we're going to put our y1 in there, and we want dx. Give it a second to think, and it's still thinking. Let's go. The absolute value is making the calculator really work. There we go, 2.3856. All right, write and evaluate an integral expression that gives a total distance traveled by the particle from t equals 0 to t equals 4. So it's the same thing. The integral, scroll up here a little, sorry about that. There we go. Integral from 0 to 4 of our velocity. And so if we go back, we're going to do the same thing. We're just going to change our bounds from 0 to 4. And that'll think for a little bit as well. And we see 1.941. Alright, is the speed of the particle increasing or decreasing at time t equals 2? So we need the velocity at time 2, and we need the acceleration at time 2. Okay, so the velocity graph is our y1. So we're going to go y1, and we're going to evaluate that at t equals 2, and we see 3/5. So the velocity at 2 is definitely positive. All right, now we want the acceleration. The acceleration is the derivative of velocity. So math 8 of our function evaluated at 2, we see negative 4.7. We call it negative 4.8. Regardless, it's negative. So our velocity and acceleration have opposite signs. And if that's the case, then the speed is decreasing at t equals 2. And finally, we need to find the position of the particle at time t equals 3. Show the work that leads to your conclusion. So this is the same thing as the other side. Our position at time t equals 3 is the position at the time we already know, which is 0, plus all the change from the time that we know, 0, to the time we're trying to find 3, of our velocity function. And there is no absolute value here. All right. And we know that x of 0 way at the top of the page is 3. So we have 3 plus the integral from 0 to 3 of our velocity function, dt. Okay, so let's let the calculator do the work here. I'll bring that back in. 3 plus math 9. And we've got 0 to 3 of our velocity function, which is in y1, dx. This is going to think for a second. We see 4.605. 4.605, and we're done.